Hello everyone. In this video, I will show how one can use the test for increasing, decreasing. Let me recall from the previous video that if f is a differentiable function, meaning that its derivative exists on the interval AB, then f is increasing if and only if f prime is positive on AB, and f is decreasing if and only if f prime is negative on the interval AB. And then we had this last piece, f is constant on AB if and only if f prime is 0, neither positive nor negative on AB. So this is what we call the test for increasing, decreasing. Now the question is how we can use it. Like, a function is given and the question asks to find the increasing, decreasing interval. So here is what we need to do step by step, how to use it. First, find the derivative of f. That's the first step. Why? You see, when you look at this table kind of thing, the left column is about increasing, decreasing, or constant. Right column is about something about the derivative being positive, negative. Now we are translating everything to f prime. So we need to start to work with f prime. Though I know that at the end I'm going to determine the f itself, if it is increasing or decreasing. But at this stage, I just need to go to f prime, find f prime. Step 2 says, find the table of sign. I want to know where the function is positive, where it is negative. Well, if you don't remember how to do this one, here is very quick review of that. Well, first thing is that find zeros of f prime, meaning that find where f prime of x is equal to 0, or where f prime is not defined. Oops, sorry, is not defined. So you find where the function, the derivative is 0, or where it is not defined. These points are very important points. We later will come back to those one, and we will see that those have a name. We call it critical point 2, 2. Then form the table. The table, you remember, the first column would be the values of x. So if you have at some point x1, it is 0, x2 it's 0, x3 is 0, and you put them in an increasing way. And then for these are values of x, then you choose a test value. So I usually did in the class this one, test value for each one, on each, between each of those two numbers, and then evaluate those ones. at f, well, in this case f prime. So it will, if you get that test value at that, it is positive, negative, well, then that will give you either positive or negative for all these things. Okay, so that was very quick review of how to do that one. Then step 3, when you're done with that, meaning that you have the table, now wherever the table is of this form, yes, you have f prime. Yes, if somewhere f prime is positive, then you add another row to your table. If f prime is positive, the function is increasing, or sometimes you just put that arrow. Or if f prime at some interval is negative, then f is going to be decreasing. Well, this way you basically have found all the intervals on which the function is increasing, decreasing. Check again. Step 1, find f prime. Step 2, find the sign table of the f prime. Step 3, basically use the test. This is what a test says. Wherever f prime is positive, f is increasing. Wherever f prime is negative, f is decreasing. So let's do an example for this. Find increasing or decreasing intervals for this function. F of x is x squared minus 4x plus 3. Let's do this one step by step. Oops. Okay, first thing first, step 1, I need to know what is f prime. Well, f prime of x, I know you know how to differentiate these guys. This will be 2x minus 4. Step 2, find the sign table for not f itself, but f prime. So we have to set f prime of x equal to 0. See where it is not defined. This guy is defined everywhere. 2x minus 4 is defined everywhere. So we only need to check these points. Okay, then find this one. 2x is equal to 4. Then x is equal to 4 over 2, which is 2. Okay, well, we are ready to draw the table. X goes from negative infinity to 2, then plus infinity. All I need two values here, test values. I'll pick 0 for this one and 3 for that. And then f prime. Remember, we are doing all these for f prime. What we know is that at 2, this guy is 0. And then f prime at 0, you plug in 0 in 2x minus 1, it is negative 4, which is a negative number. That just tells me that the function at that interval is going to be negative number. If I plug in 3, 2 times 3 is 6 minus 4, it is 2. It is a positive number. So the function f prime is going to be positive on the whole interval from 2 to plus infinity. Now, this is a step 3. Says that, well, add a table, add a row for the table. Wherever f prime is negative, the function is decreasing. Wherever the table, the f prime is positive, the function is increasing. So f is decreasing on negative infinity to 2. F is increasing on 2 to plus infinity. And that gives you everything in that example.